what these WIMP particles, weak interactive massive particles, are. They're hypothetical. We don't know that they exist.
Right.
But mathematically, they fit the bill of dark matter. The fact that they interact with gravity and with the weak force only means that no, we can't detect them. We don't have weak force detectors. We have detectors along the electromagnetic spectrum.
Right.
So everything we do when we look out in the universe, we use X-rays or microwaves or radio waves. All of those are electromagnetic.
Right.
If these particles don't interact with the electromagnetic force, that has no effect on them whatsoever.
Right.
We have no way of detecting them.
Right.
All we can do
is
since they have a gravitational pull because they have so much mass, we can just sense their gravity and be like, what the heck is going on?
Right.
Which is exactly the position we're in now.
Okay.
WIMPs were a big, they were promoted as the particle, I think starting in the 80s.
It seems like an 80s thing.
Because there, yeah, it does, doesn't it?
A little bit.
Because there was something called the WIMP miracle, and this breaks my brain.
Yeah.
But apparently, if you take the relic density, which is really unimportant for getting into here, but say the density of a WIMP, like how dense the universe would have to be for a WIMP to exist, it corresponds with the weak force number, and that made everybody say, oh, well, they're particles that don't interact with the electromagnetic force, they just interact with the weak force. Nowadays, they've kind of moved to the strong nuclear force. SIMPs. And the strong nuclear force also is found just basically in the nucleus of an atom. It's the thing that holds an atom together super tightly.
Yeah.
Holds the quarks into the proton and holds the proton in the what's the neutral charge one?
Neutron?
Yeah. The neutron and the proton together and keeps them together. That's the strong nuclear force. And they think that is probably the particle now. So
interesting.
Same thing though, doesn't interact with the electromagnetic spectrum, so we have no way of detecting it.
Right.
But it would still have mass and hence exert a lot of gravity.
So that's sort of the takeaway.
Right.
Gotcha.
Yeah.
Well, not everyone is on board with this, period. Like some people, there are some astronomers out there who say